You are watching a quiet revolution. These are Pakistani workmen, members of an age-old civilization, but citizens of a nation independent for just 2 decades. They are at work on a project which will restore the historic fort of Mangala, built 100 years ago on ruins dating back more than 5 centuries. The parched and arid land where the fort stands has been the pathway and battlefield for men and armies since the time of Alexander the Great. Today, the nation of Pakistan looks in 2 directions, to the heritage of the past and to the promise of the future. On the Jhelum River below the fort is another project, a new dam and powerhouse. Together, they will provide electricity to power a nation's expanding economy. And they will control and distribute the waters that for centuries have been both the scourge and the lifeblood of the Indus Basin. Like all people in all times, the people of Pakistan are dependent upon water. Civilizations have flourished and faded with the successes and failures of their water engineers. Without access to and some control over water, human life at its simplest and its most complex would be impossible. The record of man's response to that fact constitutes much of the history of civilization. For centuries, life in this land has been tied to the flood-washed Indus River Valley that stretches 1,000 miles southward from the Himalayas across broad, fertile plains to the Indian Ocean. For centuries, men have used irrigation systems that tap the streams and rivers, as well as underground water tables fed by the Indus and its tributaries. In the dry seasons, water was brought to the land by the plodding hoof in the dust, the turning bucket, the squeaking wheel. Thousands of wheels, thousands of men, thousands of wells. But the process of change occurs even here. In 1947, this ancient land became the new nation of Pakistan. And with the creation of national boundaries, this man's very existence was threatened. For now, the headwaters of the rivers and control of their flow lay across the border in India's Himalayan highlands. It meant Pakistan could be left without water. In 1948, the 2 nations entered into negotiations over the basic water rights to the 6 rivers in the Indus Basin. Years of high-level talks moved ahead slowly, far from the reality of the arid farmlands and their threatened wells. Unless a solution were found, the waters could be diverted upstream before reaching Pakistan. The rivers would run dry, the underground water would disappear. Pakistan could become a desert. Finally, in 1960, Pakistan and India signed the Indus Basin Water Treaty. India received rights to the waters of the 3 eastern rivers, the Sutlej, the Beas, and the Ravi. Pakistan was ceded rights to the 3 western rivers, the Chenab, the Jhelum, and the Indus. Even before the treaty was signed, the government of Pakistan was hard at work on a water development plan. 2 major dams, Tarbela on the Indus and Mangala on the Jhelum, would provide irrigation storage, flood control, and electrical power. A series of barrages and link canals would provide a system to replace the lost irrigation waters of the eastern rivers. The responsibility for managing this costly and complex undertaking was assigned to the West Pakistan Water and Power Development Authority, called WAPTA. Consulting engineers for the Indus Basin Plan were Harza Engineering Company International. To design and supervise construction of the Mangala project, WAPTA retained Binney and Partners of London. 2 years of work developed the specifications for the Mangala project. The reservoir would be contained by 2 dams, Mangala on the Jhelum and Jari 12 miles to the east. Along a low ridge between the 2 dams, the Sukian Dike would be built in order that the lake could be raised to its designed height. The main dam alone would be 375 feet high and more than 2 miles long. The construction plan at Mangala called for the boring of 5 2,000-foot-long tunnels, each 36 feet in diameter. The powerhouse design by Priest, Cardew and Ryder called for an ultimate potential of 1 million kilowatts. The Harza-designed main spillway would be almost half a mile long and have the capability of handling a maximum flow of 900,000 cubic feet per second. An emergency spillway could handle an additional 230,000 cubic feet per second. Because of the size and complexity of the job at Mangala, only 4 international groups pre-qualified and bid. Financed through the World Bank, the contract would be a fixed unit price award. On November 15, 1961, the bids were read publicly, and the award went to the low bidder, Mangala Dam Contractors, a group of 8 American firms led by the Guy F. Atkinson Company of South San Francisco. Atkinson, as managing partner, was joined in the venture by the Chicago Bridge and Iron Company, S.J. Groves and Sons Company, Charles L. Harney Incorporated, C.J. Langenfelder and Son Incorporated, Ostrander Construction Company, R.A. Trappier Incorporated, and the Walsh Construction Company. This was the group that received the world's largest peacetime competitive bid award, nearly $354 million. The contractor's work on Mangala Dam began at the Atkinson main office in South San Francisco. The first step was meetings, lots of them. Their purpose to implement the plans and procedures that would be used to build the dam. One of the early decisions, based on pre-bid studies, was to advance the completion date by a full year. But the potential danger of sudden catastrophic monsoon floods on the Jhelum River meant that closure and diversion of the river must be accomplished as early as possible in September, the end of the monsoon season. Diversion at this time would allow the maximum time to raise the closure dam high enough to withstand the next season's floods. If diversion couldn't be completed on schedule, it would have to be postponed a full year. This potential threat was the key to many other basic decisions that had to be made by the planning groups. Only the best and most modern earth-moving equipment could handle the job, and it would take the world's largest peacetime fleet to do it. $50 million worth had to be selected, ordered, and shipped at once. They would have to plan, too, for the maintenance shops, to supply warehouses, and the town to support the equipment, the men, and their families. Another assignment was to select the 500 experienced construction personnel who would supervise, train, and work with the thousands of Pakistanis who would make up the labor force. From the contractor's office in South San Francisco, from job offices in London and Karachi, and from key people around the world, things started moving toward Pakistan. In a place far from the technology and amenities of the modern world, a dam would be built. At Karachi, shiploads of equipment and supplies were now arriving. They would be transported the remaining 900 miles north to Mangala by rail. The logistics of just getting the job started were enormous. Items large and small, cheap and expensive, were on the way. Earth-moving equipment from California, diesel fuel from Asia, school books from New York, beef from Australia. And yet, within 2 months, things were underway at Mangala. The supervisory staff would be drawn from Atkinson's permanent organization. They would go to the job from many points: Los Angeles, San Francisco, Portland. There they would meet families from Liverpool, Manchester, and London, sent by the project's consulting engineer, Binney and Partners. With their counterparts in Wapta, these men would spend the next 5 years supervising the construction of Mangala Dam. This meant building the homes, the hospitals, the supermarkets, the schools, the labor camps, everything that would be needed. The first job, to organize the facilities needed to support the thousands of items and people that were pouring into the site. It meant getting the equipment and materials with which the dam would be built. And it meant building the shops needed to repair and maintain the heavy equipment. It meant building the facilities to store and repair, to service and maintain everything that was coming to Mangala. For the job of constructing an earth-filled dam isn't just piling up a lot of dirt and rock. The components of the dam would come from a variety of places. Some of it rock blasted from a quarry in the nearby hills. More material would be from a site on the Jhelum riverbed 3 miles below the dam. And there would be clay and sandstone from the surrounding hills. Over a third of the fill for the main dam would come first to the aggregate plant, where in an hour's time, 12 crushers, 26 screens, and 10 miles of conveyor belts would turn out over 3,000 tons of drain and filter rock, ranging in size from fine sand to cobbles. Yet the aggregate plant would be so highly automated that only 8 people would be required to keep the operation running at full speed. And it also meant hiring the workforce. Since the availability of trained personnel in Pakistan was not sufficient to meet the immediate demand, a local workforce must be hired and trained. Even basic skills with simple hand and power tools would have to be taught. Men who had never before seen a bulldozer or a scraper or a crane would have to become totally familiar with equipment worth thousands of dollars. The contractor used his own experienced operators to teach how to push a scraper with a cap, how to make a well, how to repair a diesel engine, how to pour concrete. Initial instruction was in English, which was then translated by Pakistani foremen.
और इस तरह और दूसरा इससे पीछे इस तरह आ जाएगा अगर इस तरह आएगा तो फिर 2 दफा टर्न करना पड़ेगा इस तरह और फिर इस तरह
The next step was to gain experience on the actual equipment. The instructors never worked their training units in an area where major operations were underway. Instead, they utilized future construction sites where even practice work contributed to the job to be done. More than 10,000 untrained but eager men learned the skills that were needed. Skills for the job at Mangala, and skills readily usable in the accelerating technology of the new Pakistan. The contractor's first year in Pakistan had been spent organizing facilities, equipment,